Hey everyone, hope you are doing well. I received a request from, I think it was Path Samwell. I apologize if I'm saying your name wrong. I'll pop up the comment. And they requested, I don't have my phone because I'm recording, but it's something along the lines of like Polygon law. But I decided they were asking about the Polygon law of vector addition. Now, this was something that I had not actually come across before, or at least I didn't, really remember this. So I looked into it and I'm going to explain my understanding and my interpretation of it. Just a side note as well, I have done requests in the past, but I am working full time, so I might not be able to do requests, especially if it's like a more complex video. And I'm quite enjoying just, making videos like I want to make as I don't have a lot of time. But if this kicks off and I can monetize my channel, I need like 4,000 watch hours, then I can definitely, put more time on this and I can, do a lot of requests. So yeah, that's just a note in case anyone is thinking about doing a request. So looking into, or I guess starting the Polygon law of vector addition, I just realized, isn't there a Pokemon called Polygon, but it's not a two-sided shape, right? I don't know. Anyway, probably not relevant. I might be wrong, but anyway, so I'm going to define a polygon and vector. So a polygon, for this purpose, I mean, you can kind of just call it a shape. It's a shape with straight sides. So you can think of a triangle, a square, what's next, a pentagon, and so on and so forth. So for example, I guess a circle wouldn't be a polygon because it's not a straight line, but it's just a combination of straight lines to make a basic shape. So that's what a polygon is. Now a vector is direction and magnitude. So one of these is a vector, and you write it like this with the line above it. And so C is, I guess, going in this direction with this much magnitude. I would get told off when I used to say, like, I don't know who told me off, but if I would say distance, that was kind of wrong because it's direction and magnitude. But I think for the purposes of this, you could probably, if you don't understand it, you could probably think to yourself, okay, look, we're going this distance this far, right? That's kind of basically what it is. So that's the definition of a polygon and a vector. Right, so now we've got the definition set. Appreciate there's a bit of writing here. So let's start with this on the left. We have been given a bunch of vectors. Now you can't like change the directional length, but you can like move them around. But we've got a pile of vectors here, A, B, C, D. Okay, and this, I guess, law or principle. And again, the person who requested the video, I don't know what kind of detail you wanted. Hopefully this answers it. But this law of power or whatever, Polygon law of vector addition is basically that. And this will work if you have at least two, I think, vectors, because the third vector will be a vector you've kind of made to complete the shape. So in this case, we have 4 vectors. So with the extra line we add in, it's going to make a pentagon. But the principle is that you take all the vectors and you put them next to each other to make a shape which is missing one line. Because if you were to draw a line to complete the shape, it is basically saying that this line is equivalent to all these vectors added together, right? I feel like that sounds really obvious, really obvious once you say it. It makes me feel like I'm missing something, but that is just the principle. That's the basic principle of it, and it is obvious when you think about it. But I feel like this theory or law would probably be very useful if you're like doing certain proofs. So, for example, if we went this far in this direction, we went A, B, C, D. Well, we could do that. We could do A, B, C, D. Or we could say, oh, let's just take Z route, because you're starting here and you're ending up, like you're literally starting here and you're ending up here. So it's the same thing either way. And I suppose that'd be useful because you can replace Z for, you know, A, B, C, D. So yeah, that's all it is. I guess you could theoretically as well say the reverse would be true, or, you know, like if you're going backwards, it's the equivalent, or if you went this way, the way to get back would be minus Z. But so you can, like, I guess, extrapolate off of that. But that's the basic principle that, you know, if you connect them to make a shape and then you put a final line in, that shape or that final line is the equivalent of the other vectors added together, which makes sense. So hopefully that's nice and clear. Hopefully that makes sense. You can let me know if you have any comments and questions. And yeah, thank you for watching the video. And thank you for the comment as well. I appreciate you, because you said you watched the other videos as well. So I appreciate that. Cool. See you later.